All right, welcome to number 4. Today we're going to be going over the real bread and butter of Excel. Like I told you, Excel is kind of, acts as a big calculator. It can not only add, two cells together, but what it can do is it can look at a whole range of cells and calculate, averages, maxes, a few different types of calculations, and we're going to show you that right now. So, like I said, to start a formula, you use the equal sign to let the computer know that it's going to be calculating. Equals max. When you get here, you can either type a parentheses and start the formula, or you can hit tab. I typically hit tab because you start running through formulas faster. So equals max, and then we're going to pick this whole range. Alright, so this is interesting. These calculations do not like NA being in there. So we'll assign that an arbitrary value. There we go. Alright, so now let's try min. Very similar setup as before, but now it's looking for the lowest number in the range. Alright, so now we know the highest number in the range right now, based off this max function, is 85, and the smallest is 77. Now what do you think the average is? Select the whole range. Beautiful. And going back to past lessons, we're going to reduce the amount of decimals just because it starts getting unnecessary sometimes. Sum. Very similar, and this is just the cumulative. And another way to do that is if you select your range, Excel will give you a nice little quick synopsis of what's going on in the data. So essentially, sum, count, and average are already calculated whenever you select a range. So that brings us to count. What count does is, as you can see, it counts the number of cells in a range that contain numbers. So as you can expect, it'll be 12 right now. Count A is a little bit different. This counts the number of cells in a range that are not empty. So this will be 12 right now. But I will change it to show you a case where count A will still be counting a cell and count won't. So we'll change this to NA. As you know, calculation kind of bugs out. It happens a lot. I'll show you how to handle that in a minute. As you can see, count A still counts at text value, where count doesn't. We can even change it to a regular text value. But we're going to change it back to a regular arbitrary number. Alright, now sum if. We're going to go over what an if function is, or just the logic of an if statement. And essentially, to break it down, it is if the sky is blue, then don't wear a jacket. If sky is cloudy, then wear a jacket. So essentially, based off an observation, it can give you two potential cases. So essentially, sum if, so very similar to the sum, but we're going to sum if, we're going to sum, how can we do this? We'll just say sum if, if it is trial, if it's a double-digit trial. So give me the sum for any numbers of the trials that are above 10. This is going to include 1, and I will actually teach you what a wildcard is. So sum if. Your range, essentially your if criteria range, your actual criteria, and then what you are summing. So essentially, what I'm telling the computer to do is sum numbers here based off of data here if it matches this. So now let's try to break this down. What criteria was satisfied? It looks like trial 10, 11, and 12, because that 1 is what we call a wild star, and it can take the place of the 0, the 1, and the 2. And it looks like it's also counting this first trial, because that's exactly what it sees. Alright, so let's see if 319 is the sum of these. And as you can see, I used Control, click to select multiple cells, and the sum is 319. Looks like that sum if is right, and we are on our way. Count if. I'm going to show you a very different use for this, and I use this all the time. I would say this is one of my secret moves. So what I'm going to do is I'm going to bring all the potentials right here, all the potential for an amount of jelly beans, and what we want to do is we want to say, hey, how many times did 78 occur? So what we do is we go down to data, we remove duplicates, We don't want to expand the selection. We only want to remove duplicates in the I column. Beautiful. I'm going to bring this over here because this is going to be for a minute. Alright, so now I'm gonna sort this for us. So we go to filter, and this is stuff I'm all going to teach you later, so don't worry. So we'll do smallest to largest. Get rid of that filter. Alright, and now bringing it back to the formula. Count if. So what we're going to do is count if. So essentially we're going to count this, and we want to say count it if it equals this value. So it looks like 77 only occurs once in this. Now let's see what else. This is my famous move as values or paste as values, just so we don't have calculations anymore. Go home to the borders. And this would be count. Caps lock goes on. Beautiful. Now we can start getting a feel for the data with just a quick count if. We can start allocating, you know, the histogram, some buckets. Alright, and lastly, I will show you a very cool function, rand between. And this is essentially a dice roll. So you say, hey, I want Excel to calculate a number random in between 1 and 6. You just give the top and bottom parameters, and it will calculate it. Every time the sheet updates, the rand between updates too. This is a very fun function. I don't use it too much. I did make a Yahtzee game, and I used it for that. But I'd say it's very good to just kind of understand Excel and how you can kind of use, you know, the dynamic aspect of it. All right, so now we went over the useful number formulas. Let's go over some useful text formulas. So essentially, there's a few text formulas that kind of tell you about the text, and then a few text formulas let you manipulate the text. So length will give you a little bit of a kind of a characteristic. It will just tell you how many characters, are in the string of text. So that's 4, as you can see, T-E-X-T. Left, the left function, what it does is it lets you grab a certain portion of the text. So hey, we'll grab this text, and let's just grab the 2 left. So we can guess that would be T and E. Beautiful. Now right works the same exact way. Grab the text. We'll take the last 2 characters. And those are really important if you sometimes have extra spaces, kind of leading zeros that you don't need for import when you import data. So those can actually be super useful for scrubbing data. Alright, so now we'll take mid. We'll do the start num will be 2, and we'll keep it for 2. So now let's get E and X. So the start would be 2, the position, and you go for 2. Now, say you have text here, but you want to make it uppercase. How can you do that quickly without manually retyping all that? You can use a proper formula, and that doesn't make it all uppercase, but what that does is that makes it proper case. So uppercase is the first letter. If you want to uppercase every letter in a string, you say upper and select the string you'd want. As you can see, originally it was lowercase and now it's uppercase. Now the inverse of that would be lowercase, and it works just as well. One formula, and this is, you know, inherently a little bit different, and I will actually combine all 3 of these. So, you know, I tell you how to merge cells. What that does is that brings multiple cells together. What if you want to bring text together? What if you want to make a combination of text cells? So what you do is you use concatenate. So it joins several texts. So you select your first text. Sorry for that. So I only have the first parameter. So what you can do is you can also use quotes. So I'll say break. Then you can select your second text, and now I'll use the quotes for a space. So all you do is a space, close quotes, and now we'll just use the last text. Alright, so just like the formula indicate, concatenate text with break, with lowercase text, add a space in there, and have a capital text. This can be very powerful, and I use this one actually very frequently. The last text function I'm going to show you is trim. And if you have extra spaces, and your data's a little bit messy, you want to really clean it up, use the trim function, and that will remove all empty spaces or all unnecessary spaces and keep your data looking squeaky clean. Date formulas are super important in Excel because a lot of times you're doing reporting, timesheets, a lot of things that revolve around dates. So there's two functions that report, they talk to your computer and they give you the live date. So essentially, if you use now and you just have to close it off, you don't feed in any parameters, hit enter, and it will give you the date and time. Now another very similar function will return the date, and that is today. What you can do now, there's other functions essentially, and I will use a dummy date. I'll use one of these. So essentially what you can do is if you want just the day parameter from this date, you say equals day, and you give it the serial number or the Excel identifier as a date. So essentially we'll feed it a date, and we're guessing it should give us 20. Beautiful. It gives us the 20th day of the month. Month is very similar. Feed it a serial number, and it will return the month. In year, anticlimactically is very similar as well. Now, what if you have, your day, month, and year in different cells, and you want to combine all three to make a super date, or just to make a digestible, readable one-cell date? What you can do is you use the date function, returns the number that represents the date. So you feed it the year, comma, feed it the month, comma, and feed it the day. And then it'll spit out the date in a nice format. A fun function with date is called datediff, or datediff, excuse me. And what that does is that gives you the difference between two dates. This is a very special function because Microsoft Excel does not recognize it and won't autofill it. So as you see, I will type out the function. There's date value and date. There's no datediff. There is. I assure you it's in there. It's a function recognized by Excel. And how it works is the first parameter is the first date. The second parameter is the second date. In the third parameter, what you feed it is... okay. 28. Okay, so now I know I'm on the right one. So that just completely crapped out. I call that a fat finger. It's when your fingers hit a button you don't necessarily intend it to. So I just want to make sure that my first date is B27, my second date is B28, close that off, and I'm not selecting D, I'm selecting M, E27, it's just hidden behind the cell, and that's M. So there's 6 parameters you can give it for this last parameter, M, D, Y, YM, YD, and MD, and I've made a little table with each parameter showing you what they'll each do. Essentially what this just did is said, hey, there's a 13-month date difference between these two dates. I'll bring this down, and this should tell me how many days. This should tell me how many years. Why didn't days work? Okay, all right. So bringing it back to the old lesson, Control-Zing that. We need to absolutely fix these. They cannot be relatively referenced. So what we're going to do is we're going to use the F4 trick. Beautiful. And now this will work. Alright, that's a 409-day difference between these two dates. It makes sense. A year is 365 days. It's 1 year. Solid. And now what we're doing is we're saying, hey, how many months excluding years? So don't look at years. How many months is January to February? How many days is January 14th to February 27th? And now this is just raw months. Very similar to this. The date diff function can be very important when working with date. Date analysis can be tricky. Calendar math is not intuitive, and Excel can really help you work around that. Excuse me. All right, lastly, we're going to go over our very useful advanced formulas. And this is for the brave souls. I actually will say these are all super simple. You might see guides online saying VLOOKUP, nested ifs. It might be intimidating, but they're actually very simple in nature. So what VLOOKUP does is it will allow you to retrieve a piece of data out of a table based off a key, a common key, we call it. So essentially, what we'll do is you can pretend this is on a whole different sheet and this is a ton of different data. So it would be a little bit more impactful in that case. We'll say, hey, trial 6 is here. We want to get the number of jelly beans for trial 6 without having to go through this table, because imagine it being super, super long. So essentially what we do is we say, hey, start the formula like always with VLOOKUP. The first parameter is the lookup parameter, or the lookup value. So you're looking up trial 6. You're looking at in this table array right here. So this is a table array. You want it to be the second column, because what we want is to retrieve jelly beans. And we want to make sure that this is an exact match on what you're matching. So that's a 0. So now trial 6 should have 82 jelly beans. Beautiful. This can be super important with dashboards, a lot of reporting, even just for simple analysis. I use VLOOKUP just to create a lot of tables and subset tables. So let's see it dynamically work. Let's change this 6 to a 9. And it worked. Beautiful. An if statement. So I kind of gave you a basic, the basic logic for an if statement. Essentially, if sky is blue, then don't wear jacket. If not, wear jacket. So essentially, observe something. If that's met, do something. If it's not met, do something else. So essentially what we're going to do is we're going to say if, what are we going to say? Okay, so essentially we'll say, let's assume the average. Actually, I'm going to bring it over here. Let's assume the average is 80. And sorry, as you can see, I'm doing this one live for a second. So we'll say the average is 80. So if above 80. If greater than 80. So what you say is you say, hey, if this cell is greater than 80, so essentially if this value is greater than 80, then say jackpot, because you got a good pack of jelly beans. If it is less than 80, because it, if it's not greater than 80, it's either going to be equal to or less. And we will say skimp. It was a skimp bag. As you can see, this is a 2-case. It allocates 2 cases for greater than or less. Now, how about if we want to include an equals case? Essentially, equals is a sweet spot. We're okay with getting 80 jelly beans. So that's what when we use a nested if. And essentially, how that works is we say, hey, if this is greater than or less than 80. So hey, if the number of jelly beans, excuse me. Oh, sorry guys. If the number of jelly beans is less than 80, so if that is satisfied, then we'll say skimp. They didn't give you enough. However, if that's not the case, let's bring up another if. So now what we'll do is we'll give it another potential for 2 possibilities. So that we have 1 possibility for that first value of true. Now we're going to have, in this false, we're going to have another if, which is 2 possibilities. And then we'll say if, you always have a parenthesis after the statement. Now we'll say if this is equal to 80, then the value if true, perfect. However, if it's not equal to 80, now we only have 1 more case. It's probably greater. So we said, alright, if it's less than 80, then it's skimp, it's too little. If it's equal to 80, then it's perfect. And now we have that last case value of false. We don't even have to include greater than 80, because it's already going to default to that. There's no more logic to test. So now we'll say jackpot. That means you got a good batch of jelly beans. We found a typo in your formula, and that's with parentheses. So I need to have 2 parentheses at the end, as you can see right here. I'm going to accept that because we had 2 if statements. You can hit no and then edit it yourself. I trust Excel in this case. Now let's see if this is right. Alright, so if it's greater than 80, it should be jackpot. If it's equal to 80, it should be perfect. And if it's less than 80, it should be skimp. It's perfect. Right now we have covered 3 different cases in a nested if statement. Those are super powerful. I know this is a pretty basic example, but it really shows the power of the nested if. Lastly, there's an if error. So a lot of times, or not a lot of times, sometimes, as you could tell when as soon as I change this to NA, as soon as I change the value to NA, you see these all go to NA. That's called an error. So essentially, we'll just make a fake error right now, a square root of a negative number. It's kind of throwing Excel off. So essentially, if we want to be able to handle errors, most of the time this should be working out. That works out. But sometimes it will get fed in a negative number. So we'll say we want to handle this. So essentially, we start the formula with equals as always. We say if error. So essentially what we do is we say, if error. So if this is an error, we have the value. Excuse me. We say if error. This is the value if there's no error. So we want to default to the regular formula because we don't care. But essentially, if there is an error, we want to be able to handle that. So what happens? We want to tell the user cannot compute. So essentially, do this regular calculation right here. But if there's an error, let's handle it. Cannot compute. So now let's take it to a regular case of square root of 1. What that does is it just does this regular formula. There's no error. But now we can make this an error, and then the cell will handle that cannot compute instead of getting this ugly green pound num. Very frustrating to work with. This is a lot cleaner and a lot more manageable. Yeah, we have just covered a ridiculous amount of ground. We went over all the basic number functions, went over some text functions, how to manipulate text, how to clean it up, went over some date functions, how to glide around with dates, find differences, super important when it comes to reporting, and lastly, these very functional formulas, the very famous VLOOKUP, and then we got exposed to the basic if logic and how that can how we can use that to our advantage in the spreadsheet realm. I appreciate you guys joining us today, and I'm very excited for next week.